Very good morning, students. This is Jay Vishakan. For this session, I'm going to take a new topic, which is impulse and momentum. Principle of impulse and momentum. Right. Impulse and momentum. Impulsive force. What do you mean by impulsive force? When a large force acts on a body for a short period of time, then the force is called an impulsive force. Let me repeat. When a large force acts on a body for a short period of time, for an example, cricket ball hit by a bat and football hit by the player, etc., or a carom board striker hits on the coin. So these are the huge amount of force which acts on a short span of time, right? So that is nothing but the impulsive force. So impulsive force, that is impulse is equal to force into time. Force into time. So huge amount of force, that is large force, acts on about a short span of time or short period of time, which is impulsive force. Now momentum. What do you mean by momentum? Momentum is nothing but mass into velocity, isn't it? Mass into velocity. So if you write in the formula m into v, this is momentum. M is nothing but mass of the body and v is nothing but the velocity of the body. See, as far as principle of impulse and momentum is concerned, the principle of impulse and momentum is useful to solve problems involving force, velocity and time. So basically it is useful to solve problems involving force, velocity and time. Right. So by impulse and momentum principle, is impulse equal to change in momentum. This change in momentum. So change in moment is nothing but final momentum minus initial momentum. So impulse is nothing but force into time, right? That is force into time. Force is either it could be vertical force or horizontal force. Therefore, summation v or summation h into time can be represented by t. Final momentum. Moment is nothing but mass into velocity. Final momentum is mass of the body into final velocity of the body minus mass of the body into initial velocity of the body, right? So this can be written as summation v or summation h into t equal to, let me take the m as m outside because it is common, so v minus u. This is the formula for impulse and momentum principle. So principle of impulse and momentum, this is the formula. So only difference between work energy principle and impulse momentum is the formula. So there work done is nothing but force into distance, right, equal to change in kinetic energy. Here the formula is summation v or summation h into t equal to m into v minus u. See, as far as work energy principle is concerned, summation v or summation h into displacement. In place of t, there it was s. And here for work energy principle of m into v square minus u square. Here mass into v minus u. So rest everything remains same. The conditions, like suppose the body is moving in the right direction, therefore this could be positive and this direction would be negative. Right? Its weight acts here, and the normal reaction and the friction. Suppose the body moves in the negative x-axis, then the negative x-axis direction would be positive and the positive x-axis direction would be negative. Right. So the same conditions. Suppose the body is moving. On horizontal. So the condition would be summation v equal to 0 and summation h is not equal to 0. Second condition, suppose the motion is upward or downwards, either upwards or downwards. Here this or this. This could be summation h is equal to summation v is not equal to 0, summation h equal to 0. Right. So wherever the body moves, that direction should be considered positive and the opposite direction as negative. Right. Let me solve a problem by using the impulse and momentum principle for better understanding. So this is the question. I am going to use the impulse and momentum principle. Okay. Let me just read out the question to extract the data. A 1500 Newton block, which is nothing but weight 1500 Newton, is in contact with a level plane. Level plane is nothing but this horizontal plane. A block of 1500 Newton. The coefficient of friction between two contact surfaces being 0.1. That means this block and the horizontal plane, which is mu is equal to 0.1. If the block is acted upon a horizontal force 300 Newton. Here it is nowhere specified that the body, that means the force is acting towards right or left. So I'm assuming the body is moving in the right direction. So 300, because it is mentioned horizontal force, whether it could be rightwards or leftwards. So but I'm assuming in the positive x-axis. What time it will elapse before the block reaches? So which is nothing but to find the time taken, which can be represented by t. Clear? And a block reaches a velocity of 16 meter per second, whether it is v or u, that is final velocity or initial velocity. Read further, starting from rest. So starting from rest means u is equal to 0, therefore v is equal to 16. So u is equal to 0, v is equal to 16 meter per second. This I convert this into the weight of the body, that is block. I am going to convert that into kg. So 1500 divided by 9.81, which works out 152.9 kg. Solution. The first thing one has to draw is the free body diagram, that is FBD, free body diagram. Its weight acts vertically downwards 1500 Newton, and an external force which is acting towards right, which has magnitude of 300 Newton. Two surfaces are in contact, therefore there would be a normal reaction which would be perpendicular to the surface of the block. When this is the motion of the body towards right, so when the body moves in the right direction, the frictional force would be opposite direction of the motion. So this is F. Right. So now As far as the condition is concerned, here the object is moving the rightward, so rightward would be positive and leftwards would be negative. So this is first. Second, since the body is moving in the horizontal direction, therefore summation h is not equal to 0. Summation v equal to 0. Let me resolve the vertical force first. Summation v is equal to 0. Therefore 0 equal to 1500 minus, that is the negative direction. N is in the that is in the positive y direction. Therefore n equal to 1500 Newton. N is equal to, that is a normal reaction, equal to 1500 Newton. Let me resolve the horizontal forces here. The horizontal forces are, so the towards right is positive, therefore 300 plus, this is negative, so minus F. F equal to mu into N, which is coefficient of friction into the normal reaction, which is equal to 300 minus mu value is 0.1 and F is 1500. Therefore summation h is equal to 300 minus 0.1 into 1500, which works out 150 Newton. By using impulse and momentum principle, impulse and momentum method, summation h into time, that is force into time, equal to mass into final velocity minus initial velocity. Directly we can substitute all those values. Summation h is 150 into t is unknown. Mass of the body is 152.9. V is given as 16. Initial velocity is 0. So therefore 150 t equal to 152.9 into 16, which works out 2446.4. Therefore t equal to 2446.4 divided by 150, which is 16.31 seconds. Right? So the procedure remains same of work energy principle. Only thing is the formula is different compared to impulse momentum and the work energy principle. Okay, the next video I'll come up with a few more problems by using the impulse and momentum method. Thank you.